Okay, welcome back, Matadors. We're now in Chapter 2, Lesson 7 of Big Ideas Math, titled Dilations. The essential question: how can you enlarge or reduce a figure in a coordinate plane? So we're talking about taking a shape and either making it bigger or shrinking it or making it smaller. Okay, that's what's called performing a dilation. Now, you may have heard that word dilation before. Usually it's associated with an optometrist, maybe putting a particular drop in your eye, and your eyes go from being at normal dilation to an enlarged dilation rate where your pupils are bigger, okay, and they can do whatever they need to do as they're checking your eyes. But that's probably where you heard the phrase dilate or dilated when you're at an optometrist and they put a special drop in your eye and your eyes become dilated, your pupils get bigger, like you see in the image there, and in the fun little image of the circle, smiley faces dropping, their eyes are getting smaller. So that would be a reduction. That their eyes, that dilation is a reduction. Their eye pupils are reducing. When you perform a dilation, there's always a point where you're performing the dilation from. It's called the center of dilation. And you can find the center of dilation by connecting the original image points to the new image points like you see here. So you have this line that's going from this point here and this point here, and then it crosses at the center of dilation. And you could do the same thing here as well with these two. They all cross at the center of dilation. These two here cross at the center of dilation. And let's see if we can do this the right way. Those two there. So everything in a dilation will always cross at one point, and that's called the center of dilation. Okay, and we'll get into that a little later. That's just to show you as a brief introduction. So a dilation is a transformation in which a figure is made larger or smaller, an enlargement or a reduction, with respect to a point called the center of dilation. So again, there's your center of dilation. Okay, let's go ahead and move on. Now, in a dilation, the original figure and its image. So remember, the original figure is the first figure, the one that you're starting off with. The image is what you end with. Okay, whether it's an enlargement, the image is bigger. If it's a reduction, the image is smaller. But you start off with the original, you make your dilation, and then you have your image. Okay, so in a dilation, the original figure and the image are similar. Okay, that's the key word here, similar. So they're not the same. Remember, they're not congruent. If they were congruent, they would be the same size, the same shape. Similar, same shape, but different size. The ratio of the side lengths of the image to the corresponding side lengths of the original figure. So the side lengths of the second shape and the side lengths of the first shape, you get a ratio if you put those numbers together. And that ratio is the scale factor. Okay, maybe you remember this word from 6th grade. Maybe you don't, but the scale factor usually has the letter K representing it. Okay, so the scale factor will usually have the letter K representing it. Okay, very similar to if you're doing slope-intercept form, the M is usually the slope, right? The B is usually the y-intercept, and those are just variables that are designating a particular meaning. And in this case, the K designates a scale factor when you perform a dilation. So let's go ahead and take a look at this example. You have a dilation from the red triangle to the blue triangle. So the original figure is in red, the image is in blue. the center of the dilation is the origin. Okay, the center of dilation is the origin. So maybe you're provided with the red triangle first, okay, and they're telling you to perform the dilation. They're telling you to perform the dilation from the origin. From the origin. Okay? Then you would be able to perform the dilation that you see here. So, center dilation is 0, 0. So let's go ahead and I'm going to mark that here. That's the center of dilation. So what's the scale factor? Let's try to find and figure out what the scale factor is. What is K? Okay, let's first try and figure out what is the K. So what is the scale factor? How can we do that? Well, let's go ahead and take a look at points B and B prime. The location of B is 2, 2. The location of B prime is 6 and 6. So do you notice a relationship between 2, 2 and 6, 6? How can you get from 2, 2 to 6, 6? What do you notice about those numbers? What would you do to the 2's to make them into 6's? Okay, if you guessed, multiply by 3, right? Times 3. You're correct. So you take the coordinates of the original figure, you multiply them by 3, and then you'll get the image's coordinates. For example, sticking with B, the location of B is 2, 2, right? The scale factor that we determine by looking, how can I get from 2 to 6? We said the scale factor is 3, and if we plug that in here and here, right, we multiply the original x and the original y by the scale factor, we'll be able to get our image's new coordinates, new location. So for B, it's at 2, 2, right, like you see here. We multiply each coordinate, the x and the y, by the scale factor, which is 3. And then we get the new coordinate of the images B prime. Okay, let's do another point, one more point before we move on. Okay. So let's take a look at A. Okay, we'll do this all in one color. We'll do this all, we'll do it all in purple. So let's take a look at A. A on the original figure is located at 0 and 2, right? So we're going to be talking about A. A is located at 0 and 2. We know the scale factor is what? We know the scale factor is 3. So we know K is equal to 3. So that means my 0 is going to be multiplied by 3, and my 2 is going to be multiplied by 3. And if you do that, what is 0 times 3? 0. What is 2 times 3? 6. So that should be the location of A prime. And where is A prime located? At 0 and 6. So 0 times 3, 2 times 3, get you to your new point. Okay? Moving on. So now we're going to actually start from scratch. Okay, we're going to start from scratch. We're going to dilate a figure with a scale factor of 3. If you want to pause the video, you can go ahead and make your coordinate plane just as you see it up on the screen, going 9 in both directions. You only need quadrant 1. And these are the vertices, these are the points of the figure. And hint, hint, sometimes I won't tell you what shape it is. You'll just see it once you graph it. But let's go ahead and let's go through that together. Okay, let me erase this. So let's go ahead and let's just start putting our points for our original figure. A is at 1 and 3. So A is at 1 and 3. So this is A. B is at 2 and 3. B is at 2 and 3. And C is at 2 and 1. So let's connect these. And so now we have our triangle. The scale factor is 3. So now we're going to take each of these vertices, and we're going to multiply every single number by what? By 3. So A, my new A, my A prime, we're going to do this in blue. Okay, my A prime is going to be 1, right? That's the original coordinate, times 3. And then my Y is going to be 3, right? My original Y is 3. And we're going to also multiply it by 3. And in green, you will find your scale factors. So what is our A prime going to be? Well, what is 1? What is 1 times 3? 3. What is 3 times 3? 9. So now you have your A prime. It's at 3 and 9, which is all the way up there. So that's your new A. A prime. Okay, I'm gonna erase these guys. And I'm gonna move this up. And now let's look at B. B prime. The original B's location is at 2 and 3, right? We're going to multiply each of those numbers by our scale factor. And once we do that, we'll get the location of our new B. So what is 2 times 3? 6. What is 3 times 3? 9. So the new location of our B is at 6, 6, and 9. So this is our B prime. And lastly, C. C prime. While C was originally located at 2 and 1, but we have to multiply each of those coordinates by the scale factor, which is 3. When we do that, we see that C is located at 6 and 3. And again, you can pause the video, you can rewind it, and watch whatever step you need to rewatch. But it is located at 6 and 3. And that's our new C. Okay, let's connect our triangle. And there we have our dilated image. So the red triangle was first. This was the original image. We used a scale factor of 3, and now this is the prime image. It's much larger, right? Now I want to do one last thing, so we can locate the point or the center of dilation. So let's do that. Let's do that in purple. What we're going to do is we're going to connect the prime point to the original point. And when you do this, it has to be done accurately with a straight line. Okay, and we're going to do the same thing for B. And C. And where do they all intersect at? These lines all intersect here, right? At the center of dilation. So let's say you're asked to identify the center of dilation of a shape that has been dilated, and they give you the images of the original figure and the prime figure. All you have to do is connect precisely straight lines from the prime to the original figure, and wherever they intersect, that's going to be the center of dilation. Okay, please leave some comments in our Schoology chat discussion. Leave some questions if you have any. You can be as particular as you need to be on that discussion board. If you're struggling with a particular question, I'm sure there are several others who are struggling with that same question. So take the initiative, ask a question if you need to, post a comment on the discussion board. Just let us know you're okay. Let us know your family's doing well. Let us know that that you're doing well, that what you need support in, whatever you need, we can try and figure that out. Please stay on top of Big Ideas Math as well, and keep checking my YouTube station for more support videos. Other than that, take care. That's the end of Chapter 2, Lesson 7 on performing dilation.